In this video, we will learn about this law of indices. Let's recall what we know about indices. 5 to the power of 3. We call this an index form, where 5 is the base and 3 is the index. The plural for index is indices. We can also call it 5 cubed, and it is equal to 5 times itself 3 times. So, what is 3 to the power of 5? It is 3 times itself 5 times. How about 7 to the power of 1? Well, it is actually equal to 7 times itself 1 time. Now, let's say we are asked to simplify 7 cubed times 7 square and express it in terms of positive indices. We learned that 7 cubed is actually 7 times 7 times 7, and 7 square is simply 7 times 7. This is equivalent to a product of 7s, and it would look like this. Now, how do we simplify this? It will be 7 to the power of 5, because there are 5 7s. 1, 2, 3, 4, and 5. Next, let's look at another example. We can write 13 square and 13 cubed in this way. Again, this is equivalent to a product of 13s, and we will have this. Can you see that there are 5 13s? Hence, the answer is 13 to the power of 5. What about 5 to the power of 6 times 5? Do you know how to simplify it? We will write 5 to the power of 6 and 5 in this way. And this is also equivalent to a product of 5s. Thus, the answer will be 5 to the power of 7, because we multiplied 5 by itself 7 times. Let's look at the examples again. Do you see any pattern? Look at the indices in these answers. Can you see that we can just add up the indices to obtain the answers? 7 to the power of 5 is 7 to the power of 3 plus 2. 13 to the power of 5 is 13 to the power of 2 plus 3. Notice that 5 can be written as 5 to the power of 1. Thus, 5 to the power of 7 is 5 to the power of 6 plus 1. Now, let's simplify this expression. We can write 8 as 8 to the power of 1. This will give us 8 to the power of 1 times 8 to the power of 9. We learned that we can just add up the indices 1 and 9. So, the answer is 8 to the power of 10. What about this expression? We add the indices 21 and 13. We get 2 to the power of 34. In general, when multiplying index forms with the same base, a to the power of m times a to the power of n, we add the indices.